Hi, and welcome to my video on pH. Today we're going to be discussing the pH scale, pH and pOH, and how to do calculations involving concentrations of hydronium and hydroxide. Make sure you have a pencil and paper, and let's begin. So many of you are already familiar with the pH scale. If not, there was an assignment where you had to create your own pH scale, so make sure that you do that this week. That's very important, and we are going to be using that. So you know that your acids are lower numbers on the pH scale on the left. So we have things like battery acid, stomach acid, as well as a lot of your citrus fruits, vinegar, things like that. And on the right, we have our bases or our alkaline substances. So mostly our cleaning solutions, things like bleach, soap, things like that. In the middle, we have our neutral, which is number 7. So our scale is from 0 to 14. 7 is neutral, that's water, and a lot of our bodily substances. Life exists at a neutral pH. So a pH scale is a way to express the hydronium concentration in a solution. It goes from 1 to 14, where 7 is neutral, less than 7 is acidic, and greater than 7 is basic or alkaline. You will see both words. And the pH scale is a logarithmic scale, meaning that each level is 10 times more acidic or basic. So this is going to be very important when we're talking about concentrations. Here's an example. So if we wanted to compare soda versus coffee, we're going to see how many times more acidic that is. So if we go over here, we see soda has a pH of 3. That's a very strong acid. But coffee only has a pH of 5. So that means that soda is 100 times more acidic than coffee. So coffee is 10 times less acidic than tomato juice, and soda is 100 times more acidic than coffee. Lemon juice would be 1,000 times more acidic than coffee, and so on. So each time you go, it's 10 times more acidic or basic. On the other side, we would say that baking soda is 10 times more alkaline than seawater. Or the Great Salt Lake is 1,000 times more acidic than pure water. So 10 times more, or basic. 10 times more basic, 100 times more basic, 1,000 times more basic. We're multiplying by 10 every time. So as our amount of hydrogen increases, the pH gets lower. As the amount of hydroxide increases, the pH gets higher. So as you might remember, when we talked about naming our acids and bases, we know that our acids generally start with hydrogen. So something like hydrochloric acid, HCl, has more hydrogen. And then we talked about our strong bases, such as potassium hydroxide. It ends in hydroxide. Our hydroxide is increasing as our pH gets higher because that hydroxide is being released in solution. So while pH measures the potential of hydrogen, pOH is our measure of hydroxide power. So it's just the opposite of our pH scale. pOH also goes from 1 to 14. 7 is still neutral, but lower numbers are more basic and higher numbers are more acidic this time. And calculating pOH from pH is actually very simple. So to go from pH to pOH, we just take 14 and we subtract the pH. To go from pOH to pH, we do 14 minus our pOH, and that's how we get that. Your pOH plus your pH is always going to add up to 14. So if you look at ammonia, ammonia has a pH of 12. It's very alkaline, which means that it has a pOH of 2, because when you add 12 and 2, it equals 14. So given a pOH, can we find the pH? Well, in this case, we have a pOH of 3. So to find our pH, we're just going to take 14, subtract 3, and we get 11. Go ahead and pause this page and answer the next two on your own. Okay, so did you get 11, 4, and 7? If so, great job. If we have a pOH of 10, we do 14 minus 10, and we get a pH of 4. Same thing with 7. 14 minus 7 gives us a pH of 7 still, because they're both neutral. Now, this is going to use the exact same concept. So if we're given the pH, we should easily be able to find the pOH. So given a pH of 5, to find the pOH, all we have to do is take 14, subtract 5, and get 9. Go ahead and pause this video and do the next two on your own. Okay, did you get 9, 6, and 7? I hope so. All we're doing is taking 14, subtracting the pH, and then we have the pOH. Fairly simple? I hope so. Okay, so now let's move on to something a little more complex. If we know so these brackets tell us concentration. So if we know that the concentration of hydrogen is 10 to the negative pH, and the concentration of hydroxide is 10 to the negative pOH. This looks a little intimidating, but I'm going to show you guys that it's actually pretty simple. Make sure that you write down these two formulas on your paper now. Okay, so what is the concentration of hydrogen if the pH is 5? Well, it's actually pretty easy. All we're going to do is put our pH, we know we're trying to find concentration of hydrogen, so we just replace pH with the number 5. Our concentration of hydrogen is 10 to the negative 5th. That's all you have to do. So what is the concentration of hydrogen if the pH is 10? Why don't you try? Did you get 10 to the negative 10? I hope so. Okay, so now let's try pOH. If we know the concentration of hydroxide, that's using this formula, if we know the pOH, what is the concentration of hydroxide? Well, all we have to do is replace pOH with 5, and we get 10 to the negative 5th. So when you're given either a concentration of hydrogen or hydronium or hydroxide ions, you should be able to calculate the pH or the pOH. So this time we're just going to work backwards. And the way we're going to do that is by taking the negative log. Now, some of you guys have not learned logarithms yet in your Algebra 2 or pre-calculus classes. If not, I'm going to show you an easy way to do this, and consider this your first introduction to logs. So what is the pH when the concentration of hydrogen is 10 to the negative 8th? Well, all we have to do is take the negative log, but the reality is we're just taking this number right here and making it positive. So the pH when our concentration is 10 to the negative 8 is just 8. That's all you have to do. So it's not so bad. When you get into logs in Algebra 2 and Pre-Cal, you'll find that they are not always this simple, but this is your first introduction. Okay, so you guys should be able to answer this one on your own. What is the pH when the concentration of hydrogen is 10 to the negative 4th? Well, if you took the negative log of 10 to the negative 4th, you'll find that this answer is simply 4. We're just taking the positive version of this exponent up here. So now we're going to work with the second equation, but again, it's the same general concept. What is the pOH when the concentration of hydroxide is 10 to the negative 9? Well, when we take the negative log of 10 to the negative 9, the log and the 10 cancel out, and negative times a negative gives you a positive, and we end up with a pOH of positive 9. Your pH and your pOH will always be positive. All right, so here's a little challenge question. What is the pOH when the concentration of hydrogen is 10 to the negative 3rd? So this time we're going to have to do two translations, or two unit conversions. First, we're going to have to go from concentration of hydrogen to pH. So our pH here is 3, which we see because we're going to take the negative log of 10 to the negative third and get a pH of 3. But we weren't asked for the pH, we were asked for the pOH, so you need to pay attention to that. If our pH is 3, all we have to do is 14 minus 3, and we end up with a pOH of 11. So that's the hardest type of problem you will see on a question like this. Okay, go ahead and copy this table down into your notes, and then I believe you guys are ready to go ahead and tackle the questions attached to this video. Good luck, and let me know if you have any further questions. Bye!